ladies and gentlemen. So I'm very happy to invite you to our evening session here, our panel discussion. That means, what can you expect? We are going to discuss the subject innovation in battery production to generate competitive advantage together with you. We have our experts here on stage, and I'm going to introduce them all to you. You see us also by the picture here behind, but I'm going to introduce them all to you. But what is very important, our experts are going to share their latest insights, and of course what we attempt to do is to answer the questions that you are going to share with us. So please make this conference your conference, share your questions with us while we are going to have started our discussion here, and then following that we will go step by step to answer the questions which have the highest rating from your point of view. Now let me quickly introduce our experts here. On the very right hand side we have Dr. Dirk Abendroth. He is the CEO of CustomCellsGroup. Warm welcome here on stage, Dirk. And Dirk states, regarding innovation in battery production to generate competitive advantage, he says, the transition into sustainable mobility is no less than a completely new way of thinking battery cells. Automotive and aviation battery cell manufacturing requires an entirely integrated design to manufacturing approach. Strong statement. We will follow up on this with you, Dirk. Okay. So then, next to Dirk, we have Michael Leipold, and he is the Director, Business Unit Plastics and Metals at Herrmann Ultraschall. So warm welcome here on stage. And Michael, he states, we are part of an industry that stands for sustainability. We all agree. But now, he adds, at the same time, the industry tolerates scrap rates of larger than 20%. And we at Herrmann Ultraschall believe a dramatic improvement is necessary. You are going to explain this in more detail during our discussion. So then we have Dr. Hannes Schmüser. He is member of the Board of Management at the DÜRR Systems AG, and he states, we must establish a strong position in the field of cell and battery production in Europe based on innovative machinery and equipment design and trustful cooperations with customers and partners. We are following up together with you on this. And then on my right-hand side, we have Dr. Saskia Wessel, and she is the Division Director, Product and Production Technology at Fraunhofer Research Institution for Battery Cell Production, FFB. And she states, for competitive cell production in Europe, we need to rethink production technology. We should not copy existing factories. This challenge can only be achieved with cooperation along the value chain. We want to learn more about this, Saskia. Okay, so with this being said, you know who is here, really high caliber experts, and in order to further substantiate these statements, we have also prepared 1 or 2 slides, and that means maybe Dirk, once the slides from your side are ready, yes, we can see it here in front and here in the back. Right now, you can tell us a little bit more about your intro statement.
Thanks very much, and thanks for having me. I keep it very short. So CustomCells is a cell developer and manufacturer. We're in business since 10 years, and we cover everything which is high performance in any kind. And we just brought a couple of our products on the bottom line. So you see battery cells with different taps, different formats, different sizes, and different chemistry inside, and obviously different manufacturing processes they need to get ready. And you see a couple of the applications. So you see, for example, in the middle, our joint venture with Porsche for high-performance cells for cars. On the left side, you see our aviation cells for eVTOLs and CTOLs, so conventional takeoff and landing and vertical takeoff and landing, both of it obviously electric. And those are actually by characteristics very difficult, say very different. The power performance and power density, especially for eVTOL, is significantly higher. You can see the big tabs on the left and right, which is obviously an indication of very high power, and obviously the format is different. And on the very right, you see some of our very specific niche products. So we follow also high-performance products, low economy of scale but high margin. This, for example, is a autonomous underwater vehicle which actually scans and maps the sea, actually finds pipeline leaks, etc. So these are a couple of our products. That's our background, and I'm very happy to discuss this topic here with you.
One short question, Dirk, because you just referred to aviation and also the automotive industry. Maybe you can elaborate a little bit more on the differences and maybe also what they have in common?
Yeah, absolutely. Those markets are totally different from our point of view. So on the one hand side, I guess everybody knows economy of scale in automotive is large. So that's obviously a benefit. The industrialization grade, the experience in automation is very high, and to a certain degree also innovation is high. But the margin always is obviously an aspect. And on the other hand side, if you look into aviation, the e-aviation case obviously is not established. So by regulation, automotive is today and here and is a given. And aviation is just about to come. And obviously, CTOL will come significantly earlier than eVTOL. And the market is fundamentally different. It's a different volume. It's a significantly higher safety demand. It is driven by certification, and the margin, in turn, is significantly higher. So that is actually what characterizes those two markets, and that actually draws back to each and everything you need to do in battery development, but also manufacturing, because the cost factor actually pulls through to everything.
Thank you very much for this additional clarification. Okay, so now I suggest we move on with Michael and also your short presentation that you have prepared.
Yes, thank you very much, Alex. So first of all, for those of you who are not familiar with the applications that we have for ultrasonic welding in battery cell manufacturing, there's actually an animation in it. So if you would be able to click once or twice to zoom in on the applications that we have. So there is the pre-welding and the tap welding of the battery cells, and then we have the bus bars obviously as one of the applications, and in case of pouch cells, also the sealing of the pouches can be done with ultrasonic.
Okay, very good. So then I suggest we move on with Hannes, and let's see what Hannes has prepared.
Yeah. Next, please. That was just my statement. Next slide. Yeah. So I've prepared three messages for you, basically three areas I wanted to emphasize here, talking about innovative production equipment. We've discussed also in the morning a lot of machinery and equipment suppliers or companies like us, also active in the field of plant engineering. And my message as follows. First of all, here you see on the left-hand side, electrode manufacturing. We need innovative products and machines. So here's some examples. You see here on the upper left, tandem or simultaneous two-sided coating. These are two technologies. Most of you know the tandem coating technology, well established. We think are very innovative technologies, in particular the simultaneous two-sided coating. We sold, and so we do the coating simultaneously on the machine. We sold such an equipment to to Cellforce, your joint venture with Porsche. That a very innovative approach, and for example, you save a lot of footprint, less capex, less dryers, and so on. Then we have R&D programs in the direction of semi-dry or dry coating. We know that dry coating is still a way to go. It's not so easy, but let's see to what it leads. We talk about resource efficiency, so reduce scrap rates. You mentioned it already, but also solvent recovery equipment. What do we do with the solvents and energy? And the energy in the whole process. And then traceability, for example, another example of innovative steps and things in the whole process, coding fingerprint to increase transparency along the whole process. So these are just a few examples talking about innovative products and solutions. Then we have the field of digitalization on the right-hand side. Here we distinguish, or you could distinguish between three different layers. We have the layer of transparency, so it's a classical database approach, data acquisition dashboards. Then we have the level in between, interconnection, digital twin, IoT, real-time data processing, and on top of it, autonomous. So here it comes based on artificial intelligence, data mining to automatic machine decisions. That all to increase value add through the whole production and value chain, to increase OEE, reduce scrap rate, etc. So the field of digitalization is something, and now we come to the next slide, please, my last one. Message number 3, partnerships. We discussed it the whole day in several sessions that partnerships are decisive and very important. So we announced a partnership between the 3 companies, Dirk, and Manz. And together we cover more than 90% of the whole production or value chain of electrode manufacturing or battery manufacturing, from mixing up to the complete pack. And so digitalization is one of these aspects to manage the interfaces and to, for example, also the interfaces between the companies and along the whole production process, how to handle the material, the foil, the coated foil, and everything, as well as the data. So data handling through the whole process, digitalization. Based on such partnerships, and this is a concrete example, we will set, and this is also linked to my statement, and develop and establish a strong position, and we have to develop a strong position against the Asian dominance. That's our mission, and we believe with all the other partners and companies and knowledge in the industry, we believe it's possible to establish and develop that in Europe.
Okay, very important insights. Maybe later on we can go back to the subject of the partnerships that you have just mentioned. Fine, so then I suggest we continue with Saskia and the slides that Saskia has prepared.
Yeah, I prepared 3 slides. So I came today from Münster. There we built up a new Fraunhofer research center for battery cell manufacturing. The target is to enable the industry for cost-efficient and sustainable battery manufacturing. How we do it? We built up a factory with a research center, so our equipment will be high manufacturing scale. We can produce mass production, but of course we operating it with under research conditions. So we ramp up always new materials and new processes. What we do there, so we start, the next slide please. We start at the beginning of the life cycle of a battery cell, so of the requirement management of battery cells. Mr. Abendroth already explained it, that we have 3 different formats, different applications. So we have to start at the requirement management and then start to build up the prototypes. The next step will be the production equipment. So we optimize and build up new production equipment, for example, the dry coating process. And then, of course, also our total factory concept and design is one of our fields where we are doing research. And at the end, of course, the materials and the sales have to go to the cycle back. So direct recycling at the cell factory is one of our research fields. And how we would like to do it, of course, here I come back to the statement of the beginning with partners. So the next slide, please. We are starting always with technologies and innovations which are coming from labs, from different partners. So up to a technology readiness level to 4 or 5. And then we start to scale it up. So we never start at the point 0 or 1. And we always start when partners are already developed innovation to the lab scale. And then our target is to scale it up to industry scale, so then the innovation can implement in a gigafactory. Thank you.
Thank you very much, Saskia. So the subject actually of innovation development, innovation creation is something that we have heard so far. And maybe, Hannes, can you tell us a little bit, how do you actually start developing innovation? It sounds, as if, you wake up in the morning, let's develop innovation, but how do you do this?
It's exactly that. I mean, first of all, there are different layers or different aspects. One is the internal, let's say, development and technologies we have in-house based on long history of coding know-how in one of our group companies. So they developed the two-sided coding process, which is an innovation in itself because it's obvious and has lots of advantages. Then, I mean, this is all based on market needs, customer needs. Then it's extremely important, and we talked a lot about cooperations and partnerships. We do that with customers and partners. And with customers, I wanted to emphasize the aspect of customers. And here again, Cellforce is one good example. It's published, so I can talk about it. You don't sell just a simple machine to a customer in terms of plug and play, and that's it. In these fields, to develop, let's say, innovative production processes, you need customers, open-minded customers, to go with you together into a joint risk or joint chance, joint technology to develop something. And so it depends pretty much on the relationship you have with the customer. And then both sides learn a lot. And that helps. So that in itself, and all the discussions by installing and commission the machine, etc., or the whole process, that in itself leads to a lot of innovation. Okay. And then, of course, partners. I mentioned the partnership. The partnership itself generates by, for instance, clarifying the interfaces in terms of data handling, a lot of innovation by putting together a complete reference production with all the potential benefits for customers. So that all in itself, that all creates innovation.
Okay, good. This point we have taken, but right now I would like to get back to this very, very strong statement that Michael made on the scrap, actually. So, I mean, what are your approaches? We have heard partnership, open-minded customers, and so on, but on the other side, we have the toleration of this very high level of scrap. So what are you actually doing to get, this down?
Yeah, I think I want to add something to the statement of Hannes before. Traditionally, we were using a lot of voice of customer the typical question would be, what keeps you up at night? So what are your biggest challenges in your production environment? That's how you generate innovation. If you add, and that's why I think partnerships are important, everybody has specific know-how. For example, we at Herrmann Ultraschall, we're only focusing on Ultraschall and the use of the technology. But we used to do this in different industries. So I was in charge of the plastics division for 8 years now. And that's why it shocked me when there in the plastics industry, usually we were talking about PPMs in terms of scrap and overall equipment effectiveness and technical availability. And these topics were really high ranked in the interviews with customers. And when I entered the industry, I was really surprised to find out that scrap rates in the double digits were accepted and tolerated and looked at as, oh, well, that's normal. And I think there's really something we need to fix. It's not even improvement. It looks to me like something's broken that needs to be fixed.
And how are you going to get this fixed?
Well, our part of the process, as I showed in my slides, is obviously not too big. But the fact that the ultrasonic is used late in the process means a lot of the value is already generated. So we're always looking, I think the biggest benefit of ultrasonic is that it is a closed loop process. So we're in contact with the part constantly, so we get valuable feedback from the process. And we collect and analyze them in our generator, more than 150 parameters. And we're always talking about a process window. So our aim is to optimize the process parameters in a way that your process window gets as large as possible. So that even with the natural fluctuation that you have from part to part, you always stay within your window and you never produce scrap. And ultrasonic is an excellent technology that is proven in other areas to basically generate zero scrap once you have a stable process.
Okay, very good point. And with this being said, I would like to get back to Saskia, because I mean, we have heard actually a lot about innovation, and I mean from a new factory that should be created, and you stated in your made in your statement that we should not copy something. So actually, which are the key innovations that you would recommend to have implemented in a new factory?
I have look on the pain points
Yes,
of the
yes.
cell manufacturing process, and then I have a look on the investment cost, of course, and the operating cost. And for the investment cost, the footprint is one of our most highest pain point, and therefore the coating process and the drying process is one of the largest equipment, and this would be the first innovation I would like to implement, that we can have a shorter process and also decrease the energy demand of this process. And the second one is, of course, the dry and clean room. It's more of 70% of the footprint of a battery cell manufacturer is dry room, and therefore the investment and also the operating costs are too high for cell and cost-efficient battery cell manufacturing in Europe.
Okay.
From my point of view.
Very good point, because right now we can connect it actually to the question, which has 5 votes here. And someone has asked, assuming dry coating makes it to market, do you think it can be retrofitted, or will it be for new factories only?
I think it can be retrofitted, but you have to substitute a lot of processes in your factory, in my point of view.
Okay, agreement?
I agree. I think it's a matter of costs finally, and it depends strongly on the basic chemistries and the other machinery, obviously.
Okay, and maybe Dirk, when you have presented your first slide, you also referred to manufacturing and also the supply chain. Can you maybe elaborate also a little bit on the combination of innovation plus manufacturing and supply chain?
Yeah, pleasure. So I spent most of my professional career actually in other industries, in automotive, in aviation, electronic software. And once you enter batteries, then at the first point in time, you get actually aware about the scrap rates, yes. And second point, you realize that the proximity between R&D and manufacturing is very, very high. It might be the highest I've seen. So that simply means that there's a closed loop. It's an iteration where you go back between manufacturing and R&D again and again and again. And well, that's normal, but usually kind of other industries have certain freezes and say, well, that's it, let's go for this, let's make another loop, and then you end up with 1, 2, 3, 4, or 5 loops, and that's it. But to continuously be in a loop is quite a difference, and that is, to me, an outstanding differentiation point for a battery industry. And that obviously requires, to a certain degree, a totally different way of thinking. Now add another ingredient, and this ingredient is, okay, let's make batteries for automotive or for aviation. So there's a guarantee for the next 15 years not to fail, or there's a guarantee to be absolutely safe for the next 15 or 20 years. And now add this ingredient into, okay, that's what I need to guarantee when I give this battery away. And then obviously all that comes back to, okay, this entire loop of development and manufacturing, including some verification in between, becomes a very, very close loop. And then you realize, okay, once you make a change in innovation of the materials, then the supply chain is part of that too. So let me summarize that in finally one sentence. To me, innovation is exactly if these 3 things come really together.
Okay, very good point. And right now we can connect it to the question which is on top of the list here. In which aspects, someone asked, do the EU machinery suppliers need to differentiate from Asian providers to be successful? Yeah. So, Michael?
Yeah, I think one aspect the Europeans are really good at is producing high quality machinery with focus on very reliable, robust processes that guarantee good OEEs. And I think that would be the niche as a European manufacturer that I would look for, because there are clear USP, in my opinion, that could be exploited. Otherwise, it would be me too. So that's the biggest gap where I see that could be filled.
Okay, maybe we can keep this subject and continue to discuss. Maybe
Yeah.
Hannes, yeah.
So I mean, it's as I said before. It's the innovative solution, and means it's basically, to answer the question, is innovation, of course. We see lots of customers struggling with, let's say, equipment they bought from Far East or so, because, for example, of the interfaces. Again, coming back to digitalization, we see lots of chances and things in terms of customer benefits, efficiency, etc., that have not been solved so far. And here we see also in the cooperation with the other two big companies a lot of chances to improve. Then it's of course total cost of ownership, digitalization, etc. But at the end of the day, talking about our cost position here, what makes our customers' life, not ours, but also in particular our customers' life right now a little bit tricky and difficult, are the subsidies from left and right, west and east. The Inflation Reduction Act, as well as the Chinese government with subsidies of up to 70% of the overall investment. I mean, we cannot fight against subsidies. Yeah? I'm not a friend of subsidies at all. I like free markets and everything, but at the end of the day, maybe it's a question back to European leaders or politics. What can we do? And I'm not asking for subsidies, but it is a very difficult situation right now.
Okay, understood. But looking at the European machinery producers, yes, Dirk?
Yeah, I would like to add on, I guess one of the key opportunities to differentiate is obviously traceability. So in aviation, it's a given. Yeah, without traceability, there's no certification, number one. And second, once you got a digital twin, once this is in place and the traceability is given, there's lots of opportunities to generate business on basis of the data. So there's an opportunity to differentiate by that. Let's put it this way, the naked cell itself is a product, but you can build a significantly larger product around this. And I guess the differentiation based on this is possible and generates value.
And Saskia, from your point of view, what makes it different, let's say, to be a European versus an Asian manufacturer?
I totally agree with the other guys, but I would like to add one point, and this is the energy demand. I think the pressure in Europe is higher to build up equipment with less energy demand in comparison to Asia, and this could be one advantage of EU machinery suppliers. And in my point of view, no supplier will reach the target on their own. They have to work together, otherwise the digitalization and traceability will not work in one cell factory.
Okay, good point. So, I mean, you have referred to the total cost of ownership and also the cost actually that needs to be reduced. And on the other side, also the factor of energy demand. We have here another question, which is also looking at the high cost of clean and dry rooms. And someone has been asking, what is the potential of mini environments in large-scale factories with regards to this? Saskia, Yes.
One of my favorite topics. So yes, I think mini environments have a really high potential for gigafactories. Of course, you decrease the volume. You have to clean and dry the area, and this is a most highest potential for a cell factory to decrease the energy demand, in my point of view.
Additions to this point? Not right now. Okay, good. So someone is asking here, Asians are king in cost control, so why should we be reinventing the wheel? What is your point on this, Dirk?
Well, I simply cannot contradict. I agree. They're king in cost control. And I think that's exactly what brings us back to your intro statement, saying, okay, we need to think it different. I think that's exactly the point. And just doing it the same way and trying to just optimize in a better way doesn't make sense.
Michael?
I agree. I fully agree with Dirk's statement. And what might be advantageous is to bring in also, as we said, innovation. I mean, combining process data, for example, from different steps in the production process and analyze it and maybe finding ways to further reduce or optimize the processes, stuff like that. There's still room for improvement and for innovation, in my opinion. without reinventing the wheel.
We
It's
would
optimizing.
Yeah.
Yes, Hannes.
Right. We would reinvent the wheel if we would provide just Me-Too technology. So that cannot be our approach. So we must have to develop some new processes, innovative solutions.
Yes.
It can't be just a Me-Too product to copy the Asian appreciated colleagues and competitors. Not at all.
Okay, but you know, exactly this point is something that someone is asking, and here we have a question with 4 votes. It is stated here, is there a risk that the uncertainty caused by a new process, for example, causes such high scrap rates that their benefits are outweighed? So, for example, dry coating, but could also be something else. It's, you know, the connection of new process, trying something new, but then scrap rates are shooting through the roof and cost as well.
I could at least give a reflection of what we have currently in the company. So we do have totally different characters. We have got, you know, very small R&D lines which run at very low economy of scale, and we do have a gigawatt scale running. And whenever a technology comes fresh from R&D into first manufacturing, you produce scrap. That's a given. So at the beginning is scrap. That's the beginning for each and every product. So whenever you just have a product, say, already in production, and you just make slight modifications, you might end up differently. That is obvious. But in the end, if you really come with a significant change, you obviously would need, and I come back to what all of the audience members here have been, panelists have been saying, R&D, the product, and the manufacturing are very, very closely connected. Just, you know, make an experiment in your mind and think about all solid state. How much of your capex you can finally reuse for all solid state? Everything most probably would need to be rethought and re-optimized. So it is, whenever the product changes significantly, it is the latest point in time to rethink your tools.
And Michael, from your point of view, because it was in your opening statement, with scrap and the new process, the uncertainty.
Well, I mean, in my opinion, introducing ultrasonic is not a new process, it's an established technology. So I cannot speak for all the other processes where I have no experience, but just that part that I can overlook, I don't see a significant risk because it's the technology that is already in use, and it's about bringing in new innovation like predictive maintenance to reduce downtime, or quicker changeover, or reducing the wear of the tools that you're using, where you can optimize. But I don't see a significant risk in the area.
Okay, good. And then we have a question which again also is focusing on the subject of scrap. And Mario Fuchs, he is asking, automotive manufacturers aim for a zero scrap strategy on steel and aluminum parts. What scrap rate is realistic for raw materials in the battery production? Maybe something for Saskia. Or the others.
So realistic, it's quite difficult. Realistic should be between 2 and 0%, or this could be maybe realistic or ambitious, but how we could realize it, and I think there are two ideas are coming up here in the plenum. The first idea is digitalization, so therefore we can implement new innovations. We will always have, in the ramp up, high scrap rates, but with the digitalization we can identify the process parameters very fast and then implement it in the highest scale faster than without digitalization. This is the first one. The second one is to direct recycle the materials at the factory. So when you have high scrap rates and it's able to integrate the material directly in the beginning of your process again, then the cost and the disadvantage of the high scrap rate is not so big. So these are, in my point of view, the two approaches which we have to implement in the new cell factories that can handle the high scrap rates of the raw materials.
You're nodding, yes.
And in addition to that, it starts with the question, where do the high scrap rates come from? Because we know many customers who really struggle. They talk about scrap rates of 30% for the final cell, after the cell comes out of the end-of-line testing. still 30%. So, and then of course also scrap rates, material along the whole process. So why do we have such scrap rates? The knowledge is not always there. Where exactly it's talking about the 15, 20 different production steps only for cells. Why? Where does it come from? So knowledge, digitalization, these are things we have to work on and to improve.
Yeah. And yeah,
I'm just questioning the question itself. Just asking a case. Well, just looking. There's so many questions on scrap, and I just come back to the initial statement, just saying, why should we reinvent the wheel? Why shouldn't we try to think it differently and just go along the path? Finally, we care about what is the overall, for example, CO2 footprint of one cell. What is the energy consumption you finally need to manufacture one good cell? Finally, that is the overall equation I'm interested in, and not in the scrap rate within a plant. If you get this kind of finally refurbished and recycled, fine. I'm just actually interested in the overall equation.
And maybe I can add something to Saskia's statement. As much as I agree with direct recycling as a good idea, I'm thinking of all the wasted production resources to produce scrap that, yes, of course, then you can recycle it. But that goes a little bit in the direction of Dirk's statement. What is in terms of the overall effectiveness and the carbon dioxide footprint, I don't consider it a very good solution. It's necessary, it's a necessity, but it would be much better to improve the processes in a way. And of course, mathematically speaking, it's a multiplication, and every factor is smaller than one, so you end up with a large or bigger scrap rate than you would want to have. But it's about optimizing all the parts of the chain, of the production chain.
I see. Okay, good. So we have recognized that the subject of scrap actually is something which is very, very important to be discussed for the audience. And of course also innovation and the total cost aspect. But we have mentioned the aspect of partnership. This was also mentioned in your opening statements. And Felix Jordan, he is asking, what are the major hurdles in establishing the DÜRR Group partnership? Was it intellectual property right? Was it the business model? And how did you actually address them to make it successful?
What were the major hurdles? I would answer more from, let's say, a positive perspective and positive side. It's a matter of trust. By chance, we found a situation, 3 companies trust each other, starting from the CEOs, of course. 3 companies trust each other, and there were not too many, not 100% right, but not too many overlaps from the product portfolio perspective. So all 3 came with the same mindset. Yes, we have to establish, we have to develop a certain position against the Asian dominance, and we can, and all are convinced there is a lot of benefit in it by optimizing the whole process. And so now we start with a reference cell or battery factory, and they all had the same targets. There were no target conflicts, and again, trust. And that makes it successful. And and then, of course, you have to go into the details, work with lots of teams and work streams, etc. So there were no major hurdles. I really have to can tell you, it's the opposite. It's trust. If companies don't trust each other or have different targets, forget it. Forget about it.
Okay,
yeah.
Clear message, Hans.
Yeah.
Very, very good. Now I see that we are coming to an end, and I have a final question to all of you. Assuming that we would have a big flip chart here in the back, and I would ask you to make a sticky note, and you have one keyword actually regarding innovation for competitive advantage in battery production. What would you put on this flip chart that we would, or on the post-it that we would put on the flip chart? The keyword, actually, the success driver. Dirk.
R&D manufacturing.
Okay. Okay. So we have, what we have discussed. So, Michael.
I think digitalization and data exchange.
Okay, good.
That was my word. Trustful partnerships.
Yes, I thought so. And
Energy demand.
okay, very good. So we have all together, we have put the post-its on our flip chart. So a big, big thank you to all of you who were here on stage. Yeah. Dr. Dirk Abendroth, the CEO of CustomCells, big thank you. Michael Leipold, the Business Director, Unit Plastics and Metals from Herrmann Ultraschall. Dr. Hans Schmüser, Member of the Board of Management from the DÜRR Systems AG. And Dr. Saskia Wessel, Division Director, Production and Production Technology, Fraunhofer Research Institute. So big thank you, and of course also a big thank you to all of you who have asked a lot of interesting questions that we were able to answer.